What happens when a star dies? Not with a whimper, but with a bang so powerful it creates a cosmic abyss from which nothing can escape. This is the terrifying reality of black holes. They are regions of space-time where gravity is so strong that nothing, not even light, can escape their grasp. This incredible phenomenon arises from the death throes of massive stars, collapsing under their own weight to form objects of unimaginable density. Black holes are not empty spaces. They are filled with an incredible amount of matter packed into an incredibly small area. The very laws of physics break down at the singularity, the point of infinite density at the heart of a black hole. What happens there? We simply don't know. Black holes are often portrayed as cosmic vacuum cleaners, relentlessly sucking up everything in their path. While their gravity is indeed powerful, it's important to remember that it obeys the same laws of physics as everything else in the universe. The gravitational pull of a black hole is only as strong as the object's mass. If our sun were to suddenly become a black hole, its gravitational pull on Earth would remain the same. We would continue to orbit as if nothing had changed, except for the lack of sunlight, of course. However, anything that gets too close to a black hole is doomed. This point of no return is called the event horizon. Once an object crosses the event horizon, there's no turning back. The spaceship would begin to stretch and distort, a process known as spaghettification. The closer it gets, the more extreme the stretching becomes until it's eventually ripped apart, its matter added to the black hole's ever-growing mass. The formation of a black hole is a dramatic event, marking the end of a star's life cycle. It all begins with a star much more massive than our own sun. As a star ages, it eventually runs out of hydrogen fuel. Without the outward pressure generated by nuclear fusion, the star's core begins to collapse under its own gravity. This collapse causes the star's outer layers to expand outward, creating a red giant. For smaller stars, this process ends with the outer layers being shed, leaving behind a dense core known as a white dwarf. However, for massive stars, the collapse continues unchecked. The remnants of the star's core are compressed into an infinitely small point, the singularity, marking the birth of a black hole. Section 4. A universe of black holes. Black holes come in a variety of sizes. Stellar black holes, the most common type, form from the collapse of individual stars. They can be several times the mass of our sun but are relatively small in size, with event horizons spanning only a few dozen kilometers. At the other end of the spectrum are supermassive black holes. These behemoths lurk at the centers of galaxies, including our own Milky Way. Supermassive black holes can be billions of times the mass of our sun, with event horizons that could engulf entire solar systems. Intermediate mass black holes, as their name suggests, bridge the gap between stellar and supermassive black holes. The existence of these different types of black holes suggests that the universe is a much stranger and more complex place than we could have ever imagined. Section 5. Warping reality. Black holes don't just warp space-time, they distort our very perception of time itself. This mind-bending concept arises from Einstein's theory of general relativity. Imagine two clocks, one on Earth and the other near the event horizon of a black hole. As time progresses, the clock near the black hole would tick slower than the clock on Earth. The closer an object gets to a black hole, the slower time passes for it relative to an observer farther away. This warping of time has profound implications for our understanding of the cosmos. Section 6. Unseen yet unmistakable. Black holes are invisible to conventional telescopes that rely on detecting light. However, their presence can be inferred by observing their effects on surrounding matter. As matter falls into a black hole, it forms an accretion disk, a swirling disk of gas and dust heated to millions of degrees by friction. This superheated material emits intense radiation, including X-rays, which can be detected by telescopes. The first direct image of a black hole's event horizon was captured in 2019 by the Event Horizon Telescope, providing compelling evidence for the existence of black holes. Section 7. A glimpse into the abyss. Black holes represent the ultimate frontier of our knowledge. They are objects of immense power and mystery, pushing the boundaries of physics and challenging our understanding of the universe. What happens inside a black hole? What happens to the information that falls into one? These are just a few of the many questions that keep scientists up at night. The study of black holes is not just about understanding these enigmatic objects, but about pushing the boundaries of human knowledge and exploring the vast unknown that lies beyond our planet.